I'm Tammy Barnes. I work for the University of Kentucky Cooperative Extension as an Extension Associate and a Nutrient Management Planner. Today I'm going to talk to you about manure analysis for nutrient management planning. So why do we want to do an analysis on manure? So basically, when I look at values that are on our calculator, they're book values. So generally, they're an estimate of the manure nutrients, but these values can actually drastically differ from the actual farm values. So why do they vary from farm to farm and from year to year? So it depends on obviously your animal species, but also your feed and your nutrition program and the nutrient content within those feeds, bedding type, the amount of bedding type. One year we may be bedding on sawdust. The next year we may be bedding on straw. Storage type, where we store our manure, outside in a stack pile, uncovered, inside covered, in a pit. Precipitation actually is a big contributor to dilution of nutrients. So we all know what kind of rainy years that we had a couple years back, that we had lots of manure pits or lagoons that were very dilute in nutrients, where in years that it's very dry, they're going to be more concentrated. So the purpose for analyzing manure. So we wanted to determine the amount of nutrients that are found in our manures on our farm. And those nutrients are basically nitrogen, phosphorus, potassium, sulfur, and some micronutrients, everything that plants need for good growth. We want to determine the concentration of these nutrients. So obviously, as going back to the lagoon, that if we have a very rainy season, those nutrients that are found in the lagoon are going to be more dilute than in years where we have less rain or we've diverted stormwater away from our liquid storage systems. We're going to use these values that we have, the nutrient levels or values in our manure analysis, along with our soil analysis, and we're going to come up with a manure application rate. And these two values, soil analysis and manure analysis, are used in our Kentucky Nutrient Management Plan and a comprehensive nutrient management plan. So the key element is that we take soil samples and manure analysis, and we're going to come up with a specific nutrient management plan for our farm. So if we're going to use manure like fertilizer, we're going to treat it like fertilizer. So in other words, we want to know the nutrients that we're land applying for crop growth. So the key to getting a representative manure sample is basically that we have to come up with some really good sampling techniques. And so the next several slides, we're going to talk about, in different situations, how we're going to actually sample that manure. But there are some things that are same from, depending on whether you're doing liquid or solids, the sampling handling is pretty similar. So basically, we want to make sure that we handle our manure sample properly, and we want to collect it properly. So the key to good representative manure sample that gives us a really good analysis is subsamples, and we want to take a lot of them. So generally, we want to take 10 to 12 subsamples from that either stockpile of manure or from several spreader loads or from our liquid manure pit. So we're going to go through the next few steps. The next thing that we really want to think about is timing. So if I'm going to land apply in April, I don't want to take my manure sample in January. That's too far ahead of when I'm going to apply. I want to land apply very close to the time that I want to sample very close to the time that I'm going to land apply. There's one disadvantage of that. So if we take it a month out from our predicted land application, there could be some nutrient changes. However, if we take samples when we're either loading the spreader or pumping the lagoon or mixing the lagoon, we're going to get a very representative sample because everything is mixed and we're actually land applying it then. However, there's a disadvantage because that analysis is not going to be available at the time that we're actually land applying nutrients. We can use estimates to come up with a rate and then go back after we get our analysis and reapply nutrients that are deficient. However, going through and actually sampling at the time of loading and then applying, if we do that for several years in a row, couple, 2-3 years consecutively, we take those averages, we can create a baseline, and then we don't have to sample quite as often. So two different types of manures. We have liquids and we have solids. So I'm going to jump in here and we're going to talk about solids or semi-solids. Generally, these are manures that are 10 to 20% dry matter. So first we're going to talk about a stacked manure or litter on the floor. So basically, we're going to take 10 or 12 subsamples, and we're going to take, about a pint each. It doesn't have to be exact measurement. It just has to be representative from that area. So in this manure, we're going to remove our crust, and then we're going to dig into that manure pile, and we're going to take our sample using a spade, or you can use a soil probe or an auger bit, but we want to get pretty deep into the pile, as deep as we can, at least a good 6 inches. Take that sample, put it in a clean 5-gallon bucket, move on to the next spots. And we're going to take some from the top, some from the side, some from the bottom, all over this manure pile. Once we get all our 12 subsamples taken, we're going to mix well in the clean 5-gallon bucket. We're going to break up the clumps, and then we're going to take 1 pint sample from that well-mixed subsample set. We don't want to overfill the bag. We want to remove the excess air and then double bag it. And then we're going to label it with owner's name, the sample ID. So we want to know whether it's beef manure, dairy manure, whether it's solid or liquid, or if it's composted. And we want to know the county. Now, if we can't get this sample to the lab immediately, we need to either refrigerate it or freeze it, especially freeze it if it's going to be several days out. So the labeling and the refrigerating and the freezing are pretty much standard across all types of subsamples, or sample types, I should say. So continuing on, there's lots of different ways to get a representative sample. We can take grab samples while we're loading the spreader. So basically, we want to load the spreader, as many times as we need to, and take 1 handful from each spreader load, put it in a clean bucket, mix it, and take our subsample. We can collect from open lots or feeding areas. We really don't want to do that because it's hard to get a representative sample. But if we have to, we're going to go on that, heavy use area. We're going to take a sample from several different areas, some by the water, some by the feed trough, some in the back corner. But in this situation, we want to take at least 10 random samples. So we're going to take a scoop of manure, kind of scrape some together in a little area, kind of mix it, take a little scoop and put it in our 5-gallon bucket. We want to make sure that we don't have so much hay. Collection during application. Now, this is probably, I would call this a double bang for your buck. So what we're going to do is basically the same thing that we did when we calibrated our manure spreader. So we're going to load the spreader up, drive over a tarp, and this tarp is going to be at least 4 foot by 4 foot. And after that spreader passes over, we're going to collect the tarp, weigh the tarp, record that weight, and then take a grab sample from the tarp. So basically, we're going to calibrate the spreader and take a manure sample at the same time. So we want to drive over that tarp at least 5 or 6 times. Next, we're going to talk about how to collect a slurry or liquid manure, which is generally 4 to 10% dry matter. The thing about liquid manures is that they have a tendency to settle. So we have suspended solids and solids that settle to the bottom of the either tank or the lagoon. So we need to recognize that phosphorus settles 8 times higher at the bottom of the lagoon. Nitrogen can be twice as high at the bottom of the lagoon than at the surface, but these are all there. The nitrogen can be very dependent on what's going on microbially in that lagoon. So we need to, just be aware that we have layers. So to get the best liquid manure sample, it's best to take it after it's been mixed for a couple hours and take it directly out of the pump, as we see in this picture here, to get the representative sample. There are other ways that we can also collect samples from while we're actually pumping it. We can have a collection pan out in the field and just, have a bucket and have it collected. We can take it from an unloading port in a tank sprayer, but we want to do that before those solids start to settle in that tank spreader. And we want to do this for several loads and always start collecting after the second load. And why that is that it allows for that lagoon to get mixed thoroughly. So to continue on, we can take manure samples, liquid samples, out of a pit. So this would be in a situation where we have slats, for example, in a swine facility, and we have small pits underneath of the slats there. This is kind of dangerous, though, because there's lots of lethal gases that can be emitted from these pits. And so when those pits are getting mixed, we need to make sure that there's there's some ventilation and that there's always somebody in the building. So I don't always recommend this, but some people would like to do this. But I think there are other ways where we can just grab it while we're land applying and just go from there. So basically, just like with our solid manure, we're going to take 10 to 12 subsamples, and all the subsamples should be mixed in a plastic 5-gallon bucket, and then we're going to mix those up very well, put them in a plastic container. We're going to tighten the lid, and we're going to tape that lid shut to prevent leakage. Once again, we're not going to fill this plastic container completely up to the top because it needs a little room to breathe. And once again, we're going to refrigerate or freeze those samples prior to their shipping if we can't get them immediately. So on the little schematic here, this is a collection tool where you would stick that down into the pit, and it has a little rubber ball. So basically, it would go down into the pit, and manure would come up into the pit up into the pipe, and then we would actually just capture it or plug it up with the ball. Let's talk about sampling from lagoons. So once again, this is a little more difficult to sample directly from the lagoon. It's usually accomplished by having a cup on a wooden pole that's 10 to 15 feet long. Once again, this is a little hazardous. We don't want to fall into the pit. Also, if there are some people that really want a great sample, they would take a boat out into the middle of the lagoon. I don't think that's really highly recommended. I think we could just get a well-mixed manure sample when we're actually land applying. So we could take a similar pipe like we saw in the previous slide and actually use that as well. So when we're taking a sample from a lagoon, we want to avoid all the floating solids on the surface, and we want to go at different depths within this lagoon. So, of course, it's kind of hard to get it from the side of the bank. So we would have to walk around the lagoon and take it from different areas. This is not an ideal way to get a good representative sample, but it is one way to do so. So now that we have our samples, they're packaged up well labeled, double baggied. We're going to send them off to the two labs that actually do manure analysis in Kentucky. One is the University of Kentucky's Regulatory Services, which is located in Lexington, or the Waters Agricultural Laboratory, which is located in Owensboro. And we can get you information for those addresses from your cooperative extension agent in your county. So basically, this analysis needs to include percent moisture in solids, total nitrogen, phosphorus, potassium, calcium analysis, magnesium, copper, zinc, iron, and manganese. Not all analysis, depending on the lab, will give you all that. So off to the right, we can see that our results are reported in pounds per ton as received. So as received means that they're going to give you a percent moisture if it's solid, or in pounds per 1,000 gallons. So once we get our analysis back, we want to be able to interpret these results. Now, if you need help interpreting the results, there are many publications out there for talking about manure nutrients and what they mean, and could give me a call. Several extension agents are pretty savvy about interpreting results as well. But all values should be either reported in pounds per ton or pounds per 1,000 gallons. If not, we need to do some conversions. The other thing that we need to look at are results to see if the phosphorus or the potassium, whether they're reported as in the elemental form, or if they are not, they need to be converted into the P2O5 form or the K2O form. And they are the typical fertilizer forms that we kind of think about when we're land applying. So you can see off to the right here is that we have a nitrogen analysis. So we have total nitrogen, ammonia nitrogen, organic nitrogen. So the organic nitrogen is the biggest percentage. That is also what we would consider a slow release nitrogen. So it is going to take only 50% of that available nitrogen in pounds per ton will be available the first year. And then it gets released slowly, the next year and the following year. Here we've seen that phosphorus has been reported both as elemental and into the phosphate equivalent, which is the P2O5. So we want to make sure that we have both those values, and if it's just the phosphorus, there are ways, elemental phosphorus, there are some conversions that are pretty simple. Same with the potash. We've got total solids and density, copper and zinc in this particular slide. Lastly, we want to understand that when we do a nutrient management plan in the state of Kentucky, is that it's phosphorus-based application. So we're land applying manure to meet the phosphorus need of that crop and not the nitrogen need of the crop. So if we were to put the nitrogen applied for the nitrogen requirements of that plant, we would be over applying phosphorus. And we'll talk a little bit later about the problem with over applying phosphorus. So we just need to keep that in the back of our mind. Now, in other states, there are nitrogen-based application rates. It just depends on the laws of the state. Lastly, I want you to remember that phosphorus and potassium are almost 100% available to that plant in the first year. So there's lots of extension publications for calculating manure application rates, and please feel free to contact me if you have any questions. Thanks.